Looking at checkpoint 3.1, yeah, checkpoint 3.1, problem number 3, determine whether the following equation defines y as a function of x. Does it define y as a function of x? So this is another way of just asking if it's a function, which we did on number 1 and number 2. We could graph this thing and look at whether it passes the vertical line test. But really, the shortcut here is I just need to make sure that y doesn't have an exponent. Thankfully, y does not have an exponent here, since it's not like y squared. Then I know that this will pass the vertical line test. In fact, I have decided to go ahead and graph it here. If I graph x squared plus y equals 5, it makes this downward facing parabola. No matter where you draw a vertical line, it only passes through once. The answer is yes, but without graphing it, all you have to do is look to see if y has an exponent of 2. Thankfully, it doesn't. We can investigate what that would look like if it did. If it were y squared, suddenly that becomes the shape of a circle, which does not pass the vertical line test. So as long as y is by itself with no exponents, then the answer here is yes. And we'll go ahead and take a look at number 4 here as well. Determine whether the following equation defines y as a function of x. Yes, it does. Number 4, evaluate the function at the indicated values. So we have this f function, negative 3x squared plus 2x minus 11. Then we have f parentheses 0, f parentheses negative x, f parentheses x plus 3. I do want to take a moment to talk about the notation here. This f is essentially naming the function. So a lot of the times we name functions f because function starts with an f. If we've already used f, then maybe we'll start using g or h because g and h come after f. Mathematicians are lazy. I mean, the name of the function could be Frank and Greg and Hank. I mean, it's just the name of the function. This parentheses x, that is not multiplication. That parentheses x, that represents the independent variable. Independent. Is there an A in independent? I think it's all E's. I don't know. Hopefully I spelled that right. That's the independent variable. It's basically just a reminder of what variable you're going to see on the right side of the equation. You're going to see variables of x. You won't see a variable of y or z or a. You're only going to see variables of x. And whenever we start replacing that x with other things, that's just telling us what we are putting in place of x. So this doesn't represent multiplication. This is not f times x. This is read f of x, f of x. Similar to how you say like the square root. You would say like square root of 5 or square root of 2 or square root of x. Whenever we say of, we're talking about evaluating a function. But really the way that we're going to handle this is we're going to take these things and we're going to plug them in. So I don't think I can do a good job of showing my work here, so I'm going to do it here. Here's our function, f of 0. I'm going to go ahead and rewrite the function, and everywhere that I used to have an x, I'm just going to leave it blank for a moment. So negative 3x squared plus 2. I'm going to run out of room. Okay, pause my recording just to scooch some things over. But this is my function. We've got negative 3x squared plus 2x minus 11. That's what we have here. But instead of an x for our independent variable, I'm going to plug in this value of 0 in its place instead. So we're just going to plug in a 0 right there and right there. And now this is an order of operations PEMDAS problem. And I'm going to shortcut this pretty quick. 0 squared is 0, 3 times 0 is 0, 2 times 0 is 0, 0 plus 0 is 0. All of this is just going to evaluate to 0, and then we're left with minus 11. So f of 0 is equal to negative 11. That will be our answer for that first bit. Now, we do also need to do the same thing, but for f of negative x. Okay, think that should give me enough room to do this. Negative 3, open parentheses, squared, plus 2, open parentheses, minus 11. So I'm just setting this up. Everywhere that I used to have an x, I'm going to set up an open parentheses, and then I'm going to take this negative x and throw it inside there. So we're going to have negative x here and negative x here. I'm going to simplify this as best as I can. Negative x squared is the same thing as negative x times negative x. And whenever you have a negative times a negative, that becomes a positive. So the negative 3, that's just going to carry through. Negative x times negative x is just x squared. Because the negative cancels because we're multiplying it by itself. X to the power of 2 is just x squared. Here we've got a positive 2 times a negative x. That would be a negative 2x. Because a positive times a negative is a negative. And then the minus 11. And there are no other ways for me to simplify this. There are no fractions for me to reduce. There's no order of operations for me to follow through on. There's no like terms to combine. This is it. There's no need for me to try to factor and solve this because those weren't the instructions. The instructions didn't say factor. The instructions didn't say solve. I don't think they did. Did they? No, it said evaluate. Evaluate. So I'm not going to do more than what they asked me to. This is all they asked me to do. That's it. Just box it and move on. All right, on to the next one, the part C over here, right? Is that part C? Yeah, part C. We're going to do part C over here. Had to slide some things around. So we've got negative 3 parentheses squared plus 2 parentheses minus 11. And I need to put an x plus 3 everywhere that I used to have an x. So x plus 3 here, x plus 3 here. Now I'm going to have to follow through and simplify this as best as I can. I have some things to distribute here. I can distribute my 2. I've got this x plus 3 being squared, so I'm going to have to write x plus 3 times x plus 3 and FOIL that out. And then I'll have to distribute the negative 3 afterwards. So that's my game plan. I am going to skip a step on the foiling, so I'm going to leave the negative 3 on the outside. If you take x plus 3 times x plus 3 and do your binomial distributing or your foiling, you'll get x squared plus 6x plus 9. I'll go ahead and distribute that 2 to get 2x plus 6, and then we just have a minus 11. Now we'll distribute the negative 3, so we've got negative 3x squared plus 6x plus 9 plus 2x. I'll go ahead and combine the plus 6 and the minus 11. I'll go ahead and combine those and make that a minus 5. And then negative 3x squared, there's nothing I can combine that with. We've got a 6x and a 2x, that's going to make 8x. And then we have 9 minus 5, which makes a positive 4. And we have done it. There's nothing left for me to simplify. There's nothing else for me to combine. There's no need to try to factor or solve or quadratic formula or anything like that because that's not what they asked us to do. So that is it for problem number 3 and 4.